Namaskar, I, Alap Mukherjee, on behalf of GuruKPO.com, is here with this session in which I will be doing the discussion on the topic error detection methods. The data link layer, which is the second layer of the OSI reference model, has three things to do. The number one, to take care of the line discipline. The number two, to take care of flow control. Number three, to take care of error detection and correction. Error detection and correction is one of the most fundamental part which the data link layer performs. Now, what is error detection? When a stream of bit is transmitted from the sender to the receiver, the data may disturb during the transmission. Now, that has to be detected, that where the data has been disturbed. So that purpose is done by the data link layer. Now there are the type of errors. There are two fundamental type of errors. Number one is the single bit error. Now in single bit error, the error may occur when a single bit of the data is changed, like from 0 to 1, or it has been changed from 1 to 0. And in the second, that is a burst error. In burst error, multiple bits can change during the transmission from the sender to the receiver. Now, the four approaches in the error detection are the VRC, which is termed as vertical redundancy check. The second one is LRC, which is termed as longitudinal redundancy check. The third one is CRC, which is the cyclic redundancy check. And the fourth one is the checksum. In today's session, I will be discussing in these two redundancy check, the LRC and the CRC. So first, we will be discussing the longitudinal redundancy check. Now in this, suppose this is the frame, means the data which has to be sent from the source to the destination. What we do is, in the longitudinal redundancy check, we place all these bytes in this form, in a row and column form. Now as we see here, a calculation is done, which is called, and the result is called the parity bit. How this calculation is done? In all the columns, we just notice that when there will be even number of ones, the result will be 0. And when there are odd number of ones, the result is 1. So in this way, the parity bit is calculated. Then this parity bit is appended to the original data which has to be sent. Now this complete frame is sent to the receiver. On the receiving end, that receiver again calculates these the parity bit of these individual data streams. If the result does not matches with this result, then we come to know that some error has occurred. Actually, while transmission, maybe some burst error has been occurred. And what are the burst errors? Means maybe when the data was sent, this was the original data. On transmission, when this data is received by the receiver, the 1 becomes 0, this 1 becomes 0, and the 0 becomes 1. Then when the receiver would be calculating these data, then the parity bit, the resultant, would not match with the resultant which was done at the source side, at the sender side. In this way, we can come to know that some bits have been changed during the transmission. In this way, the error can be detected with the help of the parity bit. Now, the second type of error detection method is the cyclic redundancy check. Now here, this concept is based on the binary division. Now what we do is, suppose this is the bit of data 100100. This is the bit of data which has to be sent from the source to the destination. Now what we do is, first we append zeros in this data, and 1101 is the predetermined divisor. This is determined by us. This is a very suitable divisor. We then divide this by this divisor, and we append zeros. The number of zeros is 1 less than the number of bits of the divisor. As we can see, the number of bits in divisor are 4. So the number of zeros which has to be appended with the original data is 1 less than the number of bits in this divisor, which is 3. 4 minus 1 is 3. So after appending these bits, we then do the binary division. 1101 multiplied by 1. 1101 is here. Then we subtract. This is the binary subtraction. So this is done as 1 minus 1 0, 0, and 1 minus 0 is 1. We don't do 0 minus 1, otherwise it would be 9. Then we just left the last bit here. Then this 0 comes. In this way, we do the binary division and we obtain the CRC remainder. This is the CRC remainder. Now what we do, when this data is sent to the receiving end, we append this CRC remainder to this original data. Like here, 100, 100, and we have appended this remainder at this end. Then we again perform the binary division taking the same predetermined divisor. We did the same binary division, and at last, if we obtain 0 remainder, then we come to know and we are sure that no error has been occurred during the transmission. All the bits which were sent from the sender side, they have been received correctly. And if the remainder is non-zero remainder, then we come to know that there have been surely some loss of any bit, or the bits have been changed. In this way, we can come to know that what error has occurred. So these were the two methods of detection of errors. In my next lecture, we will be discussing several other methods also. For more information, you can log in to www.gurukpo.com. Thank you.